that, we need to talk about what is physics. First of all, can you tell me, is physics a physical science or a life science? Physical, right? It's in the name. Physical sciences deal with non-living things. Physical science deal with non-living things. Life sciences deal with living things. So what are other examples of physical sciences? Chemistry. Good. What else? Physical science. What else? Astronomy, astrology, geology. Those are all examples of physical sciences. What are examples of life sciences? Biology, anatomy, right? Physiology, is that what you said? Zoology, good. Botany, kinesiology. Those are all examples of life sciences because they deal with living things. So physics involves the study of the physical world. Okay, and the two things that we're going to focus on in this physics class, which I'm hoping this physics class, this whole year, gets you through one semester of college physics. That's the goal, right? This class should take you through one semester of college physics, okay? And so we focus a lot on motion. We focus on energy and matter and how they relate to one another. What's the relationship between energy and matter, okay? How they move, where they move, how did they get from A to B, and how fast did they go, and why did they do that, and all that kind of stuff. Okay? Oops. Okay, so we are going to focus on energy, matter, and the relationship between those two things. We're going to start with how things move. How fast did it go? How long did it take to get there? All that kind of stuff. How far did it go? So the first questions we're going to answer are how. Second questions we're going to answer are why did it move, right? What force caused it to be in motion? That kind of stuff. All right, so math and physics. We use math as our language, right? Math is the love language of physics, okay? It is just equations. We are going to be putting tons of numbers into tons of equations. Okay, what are equations? What's another word for equations? Or, let me think about how I want to say this. An equation is the sentence, right, for a math problem. It tells us this plus this equals this, or whatever. That's our template, okay? So we're going to use a lot of equations. Equations help us quantify our observations. Quantify our observations. So physics deals with our physical world, how things move, why things move, and equations help us put quantities to that. Okay? Make sure you don't have to write down every single word that's up here, okay? I know you guys like, oh gosh, okay? Just shorthand it. Take what you think is important. I will definitely tell you when this has to be in your notes, okay? Otherwise, you can shorthand it a little bit, okay? Don't feel like every single thing that has to be up here goes into your notes. All right, so things to think about with math. Can you rearrange an equation and solve for a variable? Right? Can you rearrange an equation and solve for variables? Okay, so if I have here's my variable. Can you rearrange that equation to solve for that variable? Just take a look at it. Yes or no, we think. Right? I would hope so. We multiply those two together, we add them over, we have VI. Right? That's the type of things that you're going to be doing. This physics class is algebra-based. Okay? You'll see calculus-based physics in college. The equations look the same except they use derivatives. That's it. Okay, so this is algebra-based. So if you can do this, you can do physics. Okay? That's it. That's all the harder that the algebra gets, essentially. Okay? All right. You don't have to write this part down, but I want you to listen. This is how we solve word problems in physics. We're going to get almost all of our questions in word problem form, right? Almost all of our situations are presented to us in a word problem. So the first thing that you want to do in every physics problem is write down what you know. Okay, so it will say, Johnny went 10 meters in 4 seconds and blah, 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 right? The first thing that you do is write down what you know. And so you'll see that we start getting variables, like VI and like acceleration and like time. We'll see all those variables in our word problem, and you're going to start writing down exactly what you know. So let's say in our problem, we know that it took him 4 seconds to do whatever he's doing. I would say T equals 4. right? And I would make a list of all of my variables to help me with that problem. Does that kind of make sense? As we do problems, you'll see me do everything up here too, so it'll come second nature to you, but I want you to be aware of that. All right, what equation should you be using? Once you have all of your variables listed, you can start looking at your equation sheet and seeing what equation do I have that uses all of those variables, right? That's it, okay? What should you be solving for, and plug in your numbers. That's it, okay? This will make much more sense when we get to an equation, but I want you to understand the process we'll go through to solve word problems. Okay, rearrange and solve. When you have your answer, you need to be looking at, does your answer make sense, okay? If you are expecting him to have moved about 5 meters and your answer comes out at 5,000 meters, what does that probably mean? Any ideas? What does that probably mean? Right, I multiplied wrong, or I forgot to do a conversion. I forgot to convert from meters to kilometers or something like that. Right, so you need to check, does your answer, is it reasonable? And does it have the correct units? Okay, we will be starting to use units on every single problem, so we'll really be careful about labeling our answers with correct units. So give me some units that you think we might use in physics. How long did it take? How far did it go? Those are questions we're going to be answering. What types of units would those be? Yeah, Manju. Feet, okay. Yes, in the U.S. we'd use feet, but in science we use the metric system, so we would probably use meters, right? That's all right. That's all right. Okay, meters measures distance. What else would we probably use? If I ask, how long did it take? Right, seconds. I want to use seconds. And if I ask, how fast is it going? Okay, miles per hour is the U.S. version. Kilometers per hour or meters per second, even more so. Okay, so those are some units we'll be using, and we'll go through that as we go. Okay, check for all of these things before you move on with a problem. Okay, so as you're doing these problems, those are the things you're thinking about. Is my answer reasonable, and does it have the right units? Right? Did I label with the right units? Okay, so now we're going to get into our kind of bread and butter for today, which is measurements. We're going to be looking at how we take measurements, all that kind of stuff. So we use measurements to give our observations a quantity. Right? We use meter sticks, we use balances, we use stopwatches, we use graduated cylinders. All these things give our measurements a quantity. Okay, this right here, I need you to put in your notes, like write it in all caps or highlight it or something. This statement is so important when we are taking measurements. Okay? Read what the instrument gives you and estimate one more digit. Have you heard that before? Has anyone taught you that before? Okay, good. Read what the instrument gives you and estimate one more digit. So I'm going to draw roughly what I'm talking about here. Let's say I have a meter stick, and this is 14 centimeters and 15 centimeters. You don't have to draw this. I want you to watch and process what I'm telling you for this, okay? Okay, so let's say I have something that I'm measuring between 14 and 15 centimeters. You see what I'm doing here? We're zoomed in on a meter stick. We're looking between 14 and 15 centimeters. Halfway through, you'll see a tick mark, which means what? 14.5. And then you'll see little mini tick marks. Agreed? Have we all seen a meter stick before? We've measured with meter sticks. Great. Okay, great. Okay, so let's say the thing I'm measuring comes to here. My measurement, I'm going to read exactly what the instrument gives me. So I know it is 14 point what? 14. I know it's between 14.6 and between 14.7. Would we agree with that? This is 0.6. This is 0.7. So I've read what the instrument gives me. I know it's at least 14.6 centimeters. But I don't know that it's 14, or I know that it's not 14.7. We agree with that? So here comes your estimate. I've read what the instrument gives me. I think this falls, I would take a guess to say it's 14.6, I don't know, 6 centimeters. Do you see what I did with my last digit? Between the 0.6 and the 0.7, I think it's a smidge over halfway, so I take that estimate. we know that the last digit of every measurement is an estimate. Okay, does that part make sense? So here, I was given to the tenths place, which means I need to report my measurement to the hundredths. So read what it gives you and estimate one more. That's really important. Okay. So what happens if my thing that I was measuring ended right here? What would I call that measurement? 14 point, sorry, here's my 0.5 right here. So I would go 14.3 and then I just stop. So I think it's exactly 14.3, which means I have to include that, right? I always have to include that extra estimate. So if I think it's exactly 14.3, I add on the 0. And this part of the measurement tells me I think it's exactly 14.30. Does that make sense? That we'll talk about significant figures in a little while. That covers that. But does that make sense? Read what it gives you, estimate one more. That's super important. You guys are going to demonstrate that today in our activity. All right. Measurements are evaluated using precision and accuracy. Have you heard those two terms before? Precision and accuracy. Can anyone tell me what they mean? Raise your hand and tell me what precision means. That's your close. Flip them. That's okay. Yeah, okay, yes. Precision is how close your measurements are to each other. How close your measurements are to each other. So if you have really precise measurements, that means there is little variance or little variation between your numbers. Okay? Precision is how close they are together. You don't have to write out that bullet, just something for you to think about. How close the measurements are to each other. Accuracy, on the other hand, is what I would say is close to the actual, right? Accuracy is close to the actual. So accuracy means how close are your measurements to the real value, or what we think is the real value, the accepted value. Okay, so think accuracy means actual. All right, do we have what we need right there? Okay. And accurate. Correct measurements need to be both precise and accurate. Okay, you don't have to write this down, but I want you to think about this and discuss with your partner. I want you to think about how could you have measurements that are precise but not accurate, or how could you have measurements that are accurate but not precise? I'm going to give you about 2 minutes, and I want you to think about that with your partner and bring it back.